northeast England, a place where power stations led the way. This is Blyth Power Station. It used to be an industry leader, generating electricity for the whole of the UK. But now it's derelict, disused, and coming down. Control Demolition are back in town. Mick Williams and Dick Green are on site for a job that's potentially lethal. The team normally take on high-pressured concrete jobs in urban areas like offices, meters away from businesses, or residential tower blocks, which, if they go wrong, could wipe out hundreds of homes. But this time, they're in the middle of nowhere, so is the pressure off? No chance. Why? Because there's an electricity site next door, which could explode if hit. There'll be huge shockwaves from the blast that could cause massive damage to buildings in the area. And worst of all, the structure's made of steel. And when you combine steel with explosives, you can get shrapnel. And that's just like a huge bombshell. So what type of building could cause such destruction? This one could. This is the transfer tower and conveyors that used to be the heart of the power station, transporting coal to every part of the huge site. Built in 1958, it was the oldest coal-powered station in Britain, employing 800 people. It was the main employer for the area, but thanks to cheaper competition from abroad, the plant shut, leaving behind a large unemployment problem and many disused buildings. So here's the transfer tower that's on its way out. Plus not one, not two, not three, but 4 conveyors. It's these highlighted sections that have to go, without damaging anything else around it. During the demolition, pieces of steel could be propelled at over 300 miles per hour in any direction. Like mini missiles, they could rip through anything within 1,000 meters of the blast. And that's why the team are blowing it down bit by bit.
The problem with taking down a power station like this is it's got to be done progressively, certain bits at a time. You can't just go in and blow the whole power station down. As much as we'd like to make life simple, it's got to be done progressively. Some buildings are still being used, some buildings have to be left standing longer than others. So we have to work round the other buildings.
It's an extremely dangerous job for the team. The transfer tower is 50 meters high with conveyors going at all angles. There's 10,000 tons of metal that has to fall exactly right.
Yeah, I've done a lot of jobs, but I've not done one as awkward as this, to tell you the truth. It's a bit of a different technique in this one. It's all got to work perfect. If we get one of these conveyors that doesn't drop, it will alter the collapse mechanism totally. So we've got to make sure that everything is done right. A major problem for the team is that the transfer tower and conveyors are actually attached to other buildings that cannot be damaged in the blowdown. We can see from the back view that if the demolition goes wrong, the tower will take out this building below, which is still in use. It will also pull over this second tower. If either of these structures are harmed, then the team will have failed. Blowing down steel is a risky business. It's not like concrete that can easily be contained and protected. Steel can't be wrapped, it's too sharp. This news report shows how dangerous it can be. When blasted shrapnel was shot hundreds of meters into the air, just like a bullet from a gun. So the risks are high. The team know there can be no excuses. So here's the tower and each of the conveyor belts that have to be blown down. It works like a domino effect. The smallest conveyor, which is attached to the main transfer tower, will go first. Milliseconds later, the 2 other conveyors that are also attached to the transfer tower will blow.
Then milliseconds after that, the fourth and longest conveyor will detonate, before a final explosion sees these supporting columns pushed out. Here's the 5-point plan for blowing down steel. Cut it, attach explosives, connect it, attach detonators, add sandbags. That's the theory, but on this job, everything's a problem. The first step for the team is to prepare the structure before they put on the explosives. This is done by a technique called pre-weakening, and it's just like chopping down a tree. Wedge-shaped cuts are made in the 50-meter high steel supports to determine the direction the building will fall. The cuts at the bottom of the supporting columns have small pieces of metal called shims placed between them. These lessen the friction between the steel so that the structure will come down more easily.
We're just preparing the long conveyor columns, just for blowing out a wedge section at the front. You see we've cut a big V artery here. All we're literally doing is putting a very small explosive charge onto that piece that's now wedged in there on the shims to blow out at the same time as we blow the front legs on the transfer tower, and that's just going to start it tilting.
Here's the supporting leg. As the explosive goes off, it will push the steel shims out, allowing the structure to topple to the left. With the direction of the structure sorted out, the team select their explosives. On this job, they're using a unique-looking explosive called blade, also known as a shaped cutting charge. And it's not your average explosive because it cuts the steel rather than blasting it.
Basically, this is a shaped charge. It's an amount of explosives behind a copper liner, so when the explosive is detonated, the liner forms a slug and will actually penetrate through the steel, cutting the steel like a knife through butter.
The explosives are located on either side of this strip of copper. When they detonate, the energy from the spark forces the copper inwards before pushing it towards the structure to cut through it. Working 50 meters in the air, the team begin placing the shaped cutting charges around the steel. Each one comes in flexible strips, so it can be easily wrapped around the tubular steel supports. Taped up, they're ready for action, and the team head back down to earth.
I've done a lot of steel. It's what I've done all throughout my demolition life. So charge weight-wise, I know, nearly spot on what's required. So we've probably got about 7.5 kilos, which is about 14.5 meters of blade going off, which is going to make some crack when it goes off.
To get the extra power to heave the structure away from other buildings, the team are also using jelly mix, a type of dynamite used on thick concrete.
The kicking charges, which is jelly mix we're using on here, just to kick out pre-cut sections of steel columns, we're only probably using about 10 kilos of that. We've only small sections to knock out. The columns we've got on front that's supporting the transfer tower are not big columns, so you're only talking about a couple of kilos on each leg just to kick out the pre-cut section.
So the jelly mix will do the small job of kicking the feet out, whilst the shaped cutting charge will do the bigger job of cutting through the steel. Then come the sandbags.
Sandbags behind just force the energy created by the detonation in that direction. If we just tape that round, you'd lose a lot of the energy just back. Put the sandbags up against it, kick it against the leg.
With all this in place, a final spark, and the structure will be on its way down just right. Although this looks spectacular, it can have serious consequences. This is the National Grid electricity site, right next door to the old power station it's replaced. It provides electricity to thousands of homes. But a direct hit from blast shrapnel traveling at over 300 miles an hour could wipe it out. Here's a slow-motion film. In the center is a fizzy drinks can, and coming in from the right is a small piece of steel traveling at 300 miles per hour. That's the same speed shrapnel could fly from the blast. It rips straight through it. And even if the electricity site escapes a hit from the shrapnel, it might not be safe from this. Shock waves. During demolitions, there's a huge buildup of pressure. As the explosives begin to cut through the metal structure, pressure is released, sending out massive vibrations. Which can have shattering consequences.
It's just a loud bang, but it causes air vibration, and that'll shake out windows or force windows with the pressure straight through. So we've got National Grid right in front here. The first job we did on the conveyor on here, early on in the job we used blade and we took out £3,000 worth of windows. So at the moment we've got them all boarded up, we don't want to do that again. So that's really the only problem it causes, but it makes the bang heard for miles around as well.
Nightfall, and with sparks still flying, Mick reveals how things are going.
Well, we've got all the conveyors done. That's the 3 conveyors charged up with the shaped charges on all the horizontal beams. So that's what we wanted to get done today. And there's one little leg we've got to put some more shaped charges on, just supporting one of the conveyors. It's going well.
There's less than 24 hours to go, and Blyth Power Station is still illuminated with activity as the site workers and the team prepare for the 2 o'clock blowdown tomorrow. An ordinary morning, but no ordinary day, as another part of Blyth Power Station is about to be demolished. There's tension in the air as the wind swells across the harbour and everyone awaits the job ahead. 10,000 tons of metal will soon be on its way down, and bits of shrapnel could be flying around at over 300 miles per hour. Out on site, the team are busy preparing for the 2 o'clock blowdown.
It's a good check through everything, make sure the charges are still secure, make sure none of the sandbags are falling down or anything, they're all tight up against the legs, connect it all up ready to go, and then there's really a quick scout round.
Whilst Mick looks round across the harbour, ex-employee Jim Ord anxiously awaits the blast. Jim used to work as an engineer at the power station. He started there in 1967 and can still remember what an imposing place it used to be.
Oh, it was different from a small engineering company to a big, massive power station with 700 people there. It was quite an experience. The site was big, it was huge. When you went up in the B station on the turbine operating floor there, it just seemed to go on forever. And it was quite awe-inspiring at the time.
Jim left the station after almost 3 decades of employment. But with hours left till blowdown, he's made an emotional return.
It's very strange. It's very strange. When you see the place now, it's like a building site or a scrapyard. When it used to be pristine and the most efficient power station in Europe and the biggest and the best, and we were all quite proud of it. And then you see it now, it's moving with the times. I think I'll be pleased to see it go completely now.
And it's almost ready. One of the final safety checks is to go into the tower to make sure that all the explosives are still in the right place. On the face of it, it's very dangerous. The structure's had many sections removed, but Mick's convinced that it's safe.
Well, it's still as stable as it was originally, and we took some small pieces out of the conveyor support, but it's not weakened the structure much. It's just got the wedges wedged in place that need knocking out. So it's still a good stable structure, but once the explosives go off and remove those, it won't be so stable.
So the structure's safe, at least for the time being, and the team start connecting up. Each one of these tubes goes right into every piece of the transfer tower and the conveyors, and is linked to either the shaped cutting charge or the jelly mix explosives that will blow down the building. The demolition of tower and conveyors threatens the whole area. As a result, controlled demolition aren't the only team on the block. There's also Brown and Mason. and it's their job to ensure the 1,000-meter exclusion zone is strictly enforced because of the lethal consequences.
We're here today to fell the conveyors by explosives at 1400 hours. This is your normal safety briefing with the police and with our flag people. It's normal. So if I can just brief you, the only thing I ask you today is we have cutting charges on, which means that when I start to commence the countdown, and when just before I get to 2, 3, 1, just duck down, okay?
With that stark warning, radio checks are made to ensure the alarm can be raised if anyone enters the area.
Radio 18. Radio 19. Radio 20.
With the clock running down, the police head off to close all the surrounding roads. Only those with authorization can stay on site. Everyone else must leave the danger zone.
Precinct, and maybe turn on all at the same time.
10 minutes left, and Mick's taking care of final preparations. The exploder is primed for action.
Ready? Yeah?
Success. They're ready to go. Now, normally on blowdown day, Dick's job is to make sure everything runs like clockwork. But today, it's Mick's turn.
No.
Normally I'm tied down on these jobs, doing the countdown and the sentries, so because Brown and Mason's doing it this time, it gives me a chance to keep me thumb in and do a bit of practice.
Just 30 seconds to go. We have cameras located all around the site, ready to catch every explosion as it happens. It's time for blowdown. Blyth Power Station has been a focal point of the northeast industry for almost half a century. The transfer tower and the conveyors were the heart of the station, supplying coal to every part of the site. But it's all over now.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, fire.
Just outside the exclusion zone, ex-employee Jim Ord gives his reaction.
That's amazing, that. It's like the end of the world. A lot bigger bang, a lot more dust. I didn't realise there was as much coal still left over there. But yeah, all done and dusted now.
As the team go to examine the remains, they still don't know yet if it worked correctly. But from our cameras, it looks spot on. The smallest conveyor exploded first. Then the supports on the other two conveyors blew. Round the back of the tower, the main support on the longest conveyor went off. Then the supporting legs were kicked out, toppling it away from the other buildings. But the blast was so intense, it destroyed the signal on our camera, then completely wiped it out.
I hope Mally Sheik's going in.
Back on site, the team get their first clear view of the tower. Only 3 days ago, they were 50 meters in the air, laying explosives in the structure.
You can see it's come clean off at the top, and the conveyors are just laid here that we dropped down. The tower's right over. It's pulled the long conveyor, it launched that straight over, directly in line. It hadn't damaged the buildings right at the side, so absolutely spot on for us.
It's the same story on the other side of the structure.
As you can see, the long conveyor's perfectly flat. It got pulled over along with the transfer tower, it went over. This is a typical hinge we made when we blew out the wedges to just buckle the legs over, and it launched this section of the conveyor along with the tower, flat as a pancake. So we're worried about damaging this. We're going to keep this building if at all possible. So, absolutely spot on. It's just landed how we expected it to.
So the blowdown worked. But did the National Grid site survive? A look at the tower shows it ended up meters away from the electricity site, but the shrapnel from the blast didn't hit it. Being an explosives engineer is a pressurized job, but Mick's always got time to talk to his biggest fan.
Yeah, it came down great, Dad. All the conveyors came down, the tower over. That's my father. He rings me after every blowdown, see how things has gone. He's on the phone now, tonight. All the details, all the way through, how we did it. No, he did demolition all his life. It's what he did for a living, so he still keeps an interest in it.
As the clear-up operation continues, the controlled demolition team leave the site. The job's over. It's taken 3 days, 14 meters of cutting charges, 10 kilos of jelly mix, 300 sandbags, and 5 explosions to bring it all down.